Welcome back to the long-awaited advent of code. We are catching up on the archived 2019, which was in the year 2019. A reminder, these are the ones that I've done. Hello, DJ. Time for this to be a 10-minute stream. Well, I'm going to do a bunch of them, so I'll start with day one, but I can probably do a few in one stream. Yeah, so these are the ones I've completed. 2023 and 2022 were live, and 2020 was live. These four I've just try to catch up on the archive, so 2019 is the next one. Still have this leaderboard which people can join. So yeah, bunch of people. Umaro is there as well. I guess not many people have done 2019 because they hadn't joined since 2019, so it's there in the archive if anyone wants to catch up on it. Oh, Captain Coda also has a leaderboard here. I don't think Captain Coda has done it though. Yeah. Okay, so for those that don't know, oh, let me put the music on as well. Advent of Code is a kind of like a programming practice website written by one guy, Eric Wastel. He spends a lot of time developing these problems. He like devotes several months of the year. In fact, he's probably working on the next calendar's problems right now as we speak. Because he starts early. It takes him all year to get it sorted. So yeah, it's a set of problems, one released each day of December until the 25th. They vary in difficulty, and they're all just kind of like mathsy-minded, programmy type problems, which a software engineer should be expected to solve, even if they need to do a bit of Googling and looking at Wikipedia and stuff in order to do so. But a software engineer in general is expected to have the skills to be able to solve them. That's not always true. Sometimes they're very high on the maths end. I would say some programmers might really struggle on some of the mathsy ones, especially ones involving, like, I don't know, physics and stuff. But still, it broadens your horizons, so it's good to practice all aspects of programming. Yeah, so regardless of the fact that it's not December right now, you can play any of the previous years, and you can solve each problem. Each problem gives you 2 stars, so your goal is really to try and get all the stars if you can. So we are on 2019. I am streaming to YouTube as well, simultaneously. I'm just testing this system out. It seems to work, so... hello, YouTube. I probably won't respond to YouTube chat much, though. Okay. Shall we get started then? Day 1, you would expect to be easy, and usually it is, except last year's was actually quite tough, day 1. The tyranny of the rocket equation. Santa has become stranded at the edge of the solar system while delivering presents to other planets. Do other planets not have their own Santas? That seems inefficient. To accurately calculate his position in space, safely align his warp drive, and return to Earth in time to save Christmas, he needs you to bring in measurements from 50 stars, of course 50 stars. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. In most cases, the second star is usually harder and builds on what you've done for the first star. In some cases, the second star can actually be easier. It depends really, but usually it's harder. But usually it also uses what you did in part 1. But then again, sometimes it's independent and part 1 just doesn't matter at all, but it varies. The elves quickly load you into a spacecraft and prepare to launch. Good luck. The elves quickly... At the first go, no-go poll, every elf is go until the fuel counter upper. They haven't determined the amount of fuel required yet. What? Okay. Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, or subtract 2. Okay. I don't understand this go, no-go poll. Alright. It'll be explained, I guess. For example, for a mass of 12... blah, blah, blah. Okay, yeah, I get the calculation. Yeah, okay. The fuel counter upper needs to know the total fuel requirement. To find it, individually calculate the fuel needed for the mass of each module. and add together all the fuel values. So it's just convert these numbers via that mathematical formula. This is, if I read this right, this is possibly one of the easiest part ones I've ever seen. Yeah. It's like even parsing the input. You don't have to parse two numbers per line, it's literally just one number. Okay. And this go no poll is not relevant right now. Okay. Alright. Well. Whoops. We're not ending the stream yet. Wrong button. There we go. Alright. So we want to copy in input. So I can write this in a pretty compact way. We can say, let's just let's do some of this. Shift Alt, is it, to increase size? Yes, it is. Okay. So I didn't mention this before, but I will be using Python for all problems, because rarely do I ever see a case where I would prefer another language. In fact, never. Python is always the language of choice for me. I mean, like, maybe SQL could come up at one point, but so far it hasn't. Alright, so, with open input read only. It's good practice to just slip that in as F. Use Fortran. I haven't really touched Fortran much, but I've heard about it, mainly from my colleagues who are geoscientists, because apparently geoscientists use Fortran pretty heavily. Not for any particular reason, other than it's just very legacy and they've just never really moved on to other languages. Oh man, just realized I've got no coffee available. Unless I pop to the 7-Eleven to get a coffee. We'll see. We'll see how long this stream goes on. Alright, so with open, what are we doing? Just... we want the sum of all these things? Yes, okay. Total 0. So we want 4 line in F dot read lines total plus equal, so int line will get the integer, but then we need to do, what is it, divide by 3 and round down. So basically we do integer division by 3 and then subtract 2. Okay, so it's that divided by 3, just put brackets in case, 2. That. Fortran job good paying because no one learns language. Oh yeah, that is definitely true. Yeah, I've heard from people who do these jobs, either Fortran or some old languages, that they're like the only people available, so they have a very stable job. Hello, the poor fox. It's the middle of the night, so I can't stay. Okay, well, it looks like I'm about to complete this problem, so you'll get to see one problem complete. Just want to say how and see how you've been. Yeah, I've been alright. It's been a while since I did a programming stream. Last time was Christmas, so back into the programming mood, because there will be a new competition coming up this month, I think. No. Yes, this month on Coding Game. I'll probably stream that too. I guess this is the answer. Correct. Alright. During the second go, no-go poll, the elf in charge of the rocket equation double checker stops the launch sequence. Apparently you forgot to include additional fuel for the fuel you just added. Right. Fuel itself requires fuel, just like a module. So I guess it's like you're sending a pod with this fuel through space. So that pod needs fuel to even move. I guess that's what they're saying. Take its mass, divide by 3, round down, or subtract 2. Okay. However, that fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that would require negative fuel should instead be treated as if it requires 0 fuel. The remaining mass, if any, is instead handled by wishing really hard, which has no mass and is outside the scope of this calculation. Okay. I don't think there's any straightforward formula for this because of the rounding down. So we actually probably have to do a recursive thing. If it were not rounded down, then it would just be a sum of a geometric sequence for which there is a formula for that. Oh, damn it. My IDE is asking for a license. Is it time to renew already? Hang on, let me see. Not now, while I'm in the middle of coding. Okay, it looks like I have to do this. Alright, this will just take a minute. Hex the Pirate. Well, no, this is a proper license I have, using my old university email account. And apparently PyCharm has not realized I've left university for over a decade, but I still have my my student email account, so apparently I can just keep renewing it with that account. But I just need to do that by logging in. They could have given me a warning ahead of time. Alright, so log into my student account. For educational use only. Yeah, this stream is educational. I would hope. Continue. Okay, we're good. I remember getting tons of free licenses from Microsoft products because I was in college. Yeah, you do. Yeah, you get loads of stuff. You can even get some video games with a student license. The developers of This War, what was it called? This War of Mine are giving that free to schools. And some of the Zachtronics games, but I don't know if it's university license or school license. Actually, it's probably school license. But yeah, some of the Zachtronics games are free for kids. Although those are really hard games, so I can't imagine. They must be really smart kids to be playing Zachtronics games. Alright. We're back. You should totally stream Space Game. Well, I already did stream most of it. Like last year. I got all the way to the last level. And I am going to come back to it, but I kind of forgot about it. Well, I put it on hiatus because it was just too much for my brain to handle. Like, but I did get to the final level. So there will be a last... I don't know how many streams it'll take me to beat the final level. It looks like it's quite hard. But apparently Zach himself has never beaten his own final level of his game. That being said, I don't think it's considered to be the hardest level. I think I've already passed the hardest level, but the final level is probably the second hardest. So yeah. Several people have brought up Space Chem in the past few days, so I actually might do that quite soon. Because I don't want to move on to the next Zachtronics games until I've got that out of the way. It's not nice to leave that hanging, but... A custom tournament, that's something awful. Let's play people ran. A custom tournament? How did that work? I know there's a Space Chem community in Discord where they actually run tournaments. It looks insane though, like it looks really difficult because they basically have custom puzzles made for the tournament. They look really hard. Okay, so it looks like this is just a recursion. We want to use recursion here. I don't know how much depth we would go, but it doesn't look like it'd be much because you're dividing by 3 each time, so that number will get small pretty quickly. So they make custom maps problems. Yeah, there's a map generator in the game, I think, so you can just make your own problems. I mean, basically you make the requirements because there's nothing in the... Oh, well, there is sort of a map. Yeah, you can position... Positioning does matter. So yeah, you can also position pipelines and stuff, but mostly I guess it's just down to the ingredient lists. The tournament was point-based with points given for efficiency with symbols and number of turns. It might be fun to join a tournament like that, but I feel like the people who enter such a tournament must be pretty insanely good at Space Chem, because it's quite a niche game now. And even Zachtronics don't really promote it much because they feel like it was not their best work and they think they learned a lot from it in their new games. In particular, they think they made it too hard. Alright, so part 2. So we want a... Define recursive... What is the word we use here? Fuel. Recursive fuel amount, I guess. Of a certain mass. So... If m is less than or equal to 0, return 0. That's the base case. Right? And then otherwise we return, so it's going to be m over 3, so it's plus 2, no, minus 2. Wait, Zach is the reason we have Minecraft? Really? Was Zach an inspiration for Minecraft? I thought those games came later. I know that Dwarf Fortress was one of the biggest inspirations for Minecraft. I don't see any connection though between the... One of his first web games inspired Notch. Oh, right, yeah, he did have a bunch of web games before Space Chem. Oh, I think I read that, yeah. Oh, it was Infiniminer, wasn't it? Was Infiniminer Zach's game? It is Infiniminer. Oh wow, that is a lot like Minecraft. It looks so much like Minecraft. Yeah, makes sense. So we want a variable here, x equals that. And basically we return x plus the recursive call on x. So this should only go a few levels of depth. It shouldn't go over 1,000. All right, let's clean this up a bit. Let's say that, and then the recursive one can just use that formula. Like that. Okay, and then here we can just say total 1 will be fuel of int line. Total 2 will be the recursive fuel of int line. Okay, will this work? I don't know if I've got the recursive base case done completely correctly. Let's try this. Not correct. I had a feeling it might not be correct. Let me have a look at this. Sum of requirements for all modules on your spacecraft when also taking into account the mass of the added fuel. Oh! You've got to subtract the original mass because I'm adding that in. So all those masses, it's correct to add them all up, but the one mass you've got to discard is the original mass because that is the spacecraft itself. So we want to keep the recursive formula the way it is. We do want to add that in, but when we make the call, it would have to be like this, minus int line, just to take out that first one, I think. I think that's the problem. Nope. Why did that happen? Recursive fuel of int line minus int line. What? So... hang on. Recursive fuel, it'll be M. Oh no, it's not adding in the spacecraft's mass. No, okay, so that's correct. Let me have a look at this again. So, what exactly do they mean by fuel requirement? Let me check the semantics here. All right, we'll try the example. So the example they've given. Okay, start with 14. Nice and easy. Print rec. Actually, we don't have to do this. We could just do that. So 14, 2, and 0. But we haven't. So we've ignored the first amount of fuel. Something's gone wrong then. So we've got 0 from this, so it's... So it's fuel of m, which is m divided by 3 minus 2, plus it could go negative. The result could go negative even if the mass wasn't negative. Whoops. Okay, so it should be... We're gonna have to say max of 0 and that. It's never allowed to go below 0. That's 2 and 2, there we go. Alright. I suspect that will be the correct answer now. 5218. This was not actually an easy problem for a part 1, for day 1. Oops. Correct. Yeah, I mean, I still think it was easy, but for a beginner, that's not particularly easy. Recursion is quite tricky to get your head around, and this wasn't just, you know, textbook recursion. It was a little bit of a catch in the way you have to write it. So, I would say that's a tricky day 1 for the beginners. Cool. Move on to day 2 then. Let's update the stream title. Day 2. Oh, I'm gonna update the YouTube one as well. Oh, can't do that from this browser. Doesn't matter. Alright, day 2. 12:02 program alarm. On the way to a gravity assist, we'll go check out all the Wikipedia links. Gravity assist. Yeah. I know about gravity assist from The Martian. Also from the game, what's it called? Kerbal Space Program. I should go back and play Kerbal Space Program sometime soon. I watched Interstellar recently, and that makes me want to play Kerbal Space Program. Apparently the second game is not that good, but I still have the first game. Okay, so, your ship computer beeps angrily about a 12:02 program alarm. This is a NASA thing. 12:02. Armstrong says it's a 12:02. Aldrin says 12:02. Pause. Don't fully understand what is meant by 1202. Okay, we'll look into that further. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. Ah, the ship computer bursts into flames. We've got a Wikipedia link for halt and catch fire. Ah, okay, so it's like a machine code. It's basically a crash. It is actually just a crash, isn't it? Right. You notify the elves that the computer's magic smoke... Oh my god, how many Wikipedia links do we have to read? We've got to read them all. Magic smoke. Caustic smoke. Okay. Seems to have escaped. That computer ran int code programs like the gravity assist program it was working on. Oh, this is me talking. I didn't know that my character talks much. I thought I was a mute elf. The gravity assist program it was working on. Surely there are enough spare parts up there to build a new int code computer. An int code program is a list of integers. Yeah, I'm not going to open that link. Separated by commas. To run one, start by looking at the first integer. Here you will find an opcode, either 1, 2, or 99. The opcode indicates what to do. 99 means the program is finished and should halt. Encountering an unknown opcode means something went wrong. Opcode 1 adds together numbers read from 2 positions and stores the result in a 3rd position. So it takes 3 parameters. The 3 integers immediately after the opcode tells you these 3 positions. Alright, that's straightforward enough. Opcode 2 does multiplication instead of addition. Okay, I don't need to read all this. I think I get it. Once you have a working computer, the first step is to restore the gravity assist program to the 1202 program alarm state it had. Okay. To do this, before running the program, replace position 1 with the value 12 and replace position 2 with the value 2. What value is left at position 0 after the program halts? Okay, so the program is modifying itself. Okay. That's the program. Okay, so program equals f.readline dot split, let's say int x for x in dot split on the comma. So that just gets the program. Before running the program, replace position 1 with the value 12. Okay. We have to change this, like, so we go program 1 equals 12. and then 2 equals 2. Okay. Program 2 equals 2. Okay, so let's say let's have a thing called program counter, and this is just what index we're looking at, so it starts at 0 while true. So each step we look at the number that we're on. In this case, it would be 1. Okay, so if opcode equals program 0, not 0, whatever PC is set to. So if opcode equals 99, that is the halt, so we break. If opcode is 1, so in this case, we're doing the addition. So we do program PC so it's going to be, we take whatever PC plus 3, that's the way we store the number. So whatever number is there, that's where we're going to store the result. So program of that is going to be set to program PC plus 1 plus program PC plus 2. Those two numbers together. Multiply if it's opcode 2, and if it's anything else, which I don't think would happen, but if it does, an error, because that might be something they've slipped in there, so it halts if that happens. So either way, we want to print whatever is in location 0. Try that. Oh, I forgot one very, very important thing. We have to increase the program counter by 3. By 4 even. One, two, 4. Time to listen to the fans start to spin up. Yeah, they were about to start up when I was in that infinite loop. Incorrect. Okay. Let me make sure I've done these opcodes correctly. Oh. Okay, there's something important here I've done wrong. Here it is. These are reference numbers, not values. So you should read the values at positions 10 and 20. You don't use the numbers 10 and 20. So this should be program, basically. Whatever is at PC plus 1. There we go, that's a bigger number. Yeah, 124 is a bit small. Easy to guess. Part 2. Good. The new computer seems to be working correctly. Keep it nearby during this mission. You'll probably use it again. Real int-code computers support many more features than your new one, but we'll let you know what they are as soon as you need them. So we're now using whatever the result is for the next part. So what the program looks like at the end. Okay. So we need to make sure we've actually set all the numbers correctly, because all we know is we got the first one correct. Hopefully the algorithm is correct for all of them. However, your current priority should be to complete your gravity assist around the moon. For this mission to succeed, we should settle on some terminology for the parts you've already built. Int-code programs are given as a list of integers. These values are used as the initial state for the computer's memory. When you run an int-code program, make sure to start by initializing memory to the program's values. Position in memory is called an address. So the first value in memory is at address 0. Yeah. Is this different to what they said before? I think they're just kind of reiterating. Well, okay. Opcodes mark the beginning of an instruction. The values used immediately after an opcode, if any, are called the instruction's parameters. For example, yeah, that's fine. The address of the current instruction is called the instruction pointer. So I've been saying program counter. We can call it instruction pointer instead, maybe, just to be in line with what they've said. It starts at 0. This is always 4 for the add and multiply. With terminology out of the way, we're ready to proceed. To complete the gravity assist, you need to determine what pair of inputs produces the value. Oh god, we have to reverse engineer. Oh no. The inputs should still be provided to the program by replacing the values at addresses 1 and 2, just like before. In this program, the value placed in address 1 is called the noun, and the value placed in address 2 is called the verb. Each of the two input values will be between 0 and 99 inclusive. Oh, so we could just try all values, probably. Once the program is halted, its output is available at address 0, just like before. Each time you try a pair of inputs, make sure you first reset the computer's memory to the values in the program. Don't reuse memory from a previous attempt. But are we using... But we are using the output from part 1, are we? No, we're not. Each time you try a pair of inputs, reset the computer's memory to the values in the program. Your puzzle input. Okay. Alright. So we're not actually... Okay. Alright, well first, there's a way we can clean this up. We can say, we can define a function. Define... So, for a given two values, which are going to be what we put in position 1 and 2, we want to spit out whatever the result is. So what we do is, so it's like get result for given A and B, which will be the two values. So if we do this, we want to create a copy of program, but it's like a clean copy. So we'll say temp program equals, so it'll be like program like that. So it's a copy. So it's not going to alter the original program. And then we just do this. Let's move this. So it can never infinite loop because it's always going forward by 4 each time. We don't want to print that. We'll just break out of the loop. So there's two places it can break, either 99 or if it gets an invalid instruction. I assume we won't go past the end of the yeah, it's fine. Okay, so I'll use IP instead of PC. IP equals 0. IP, so that we need to set program 1 equals A. Say run program 2 equals A, B. Let me do that. Opcode equals that. Blah, 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 blah. IP plus 4. So when we're out of this, we return. I'm using the wrong program here. Oh, this line's really long now. And, oh, damn it, we need to change all these to IP. And do a find and replace. Okay, would have been faster just to... Can't even find the button for it. How do I find and replace? How do I find and replace? One of the most important things. Control R, but why isn't it on the... Oh, there we go. PC replace with IP. Okay, that's all. Or space. Oh. There we go. Oh, whatever. Close enough. Okay. Okay, close the window now. How do I close the find menu? It's just taking up space there. Ugh, okay. Oh, I left lots of spaces. Okay, whatever. Return temp program 0. And then it discards all the memory. So this will actually be use 12 and 2. Print get result using 12 and 2. Let's make sure we get the same result. 2894. Yep. All right. So now for part 2, basically we do for A in range. So we try every number. So what was the range? 0 to 9. 0 and 9 to 99. Okay. So 100. for B in range 100. So what they want is okay, if get result A, B equals this, just print our answer. We want 100 times A plus B. Break. That would just break out of the B. Good enough. Right. 9342 is fast enough. Correct. That was in some ways easier than part 1, although it requires a bit more reading comprehension, but I reckon beginner programmers would actually find that one easier. You just know how, you need to know your lists and how to manipulate lists, which a lot of people get wrong, to be fair. Alright, day 3. Ooh, 2D grids, yay. Manhattan distance, I like that. Alright, let me just update the... Oh yeah, I can't change that. From OBS I can change the Twitch to 3. Okay. So, crossed wires. The gravity assist was successful and you're well on your way to the Venus refueling station. During the rush back on Earth, the fuel management system wasn't completely installed, so that's next on the priority list. Opening the front panel reveals a jumble of wires. Specifically, 2 wires are connected to a central port and extend outward on a grid. You trace the path each wire takes as it leaves the central port, 1 wire per line of text. The wires twist and turn, but the 2 wires occasionally cross paths. To fix the circuit, you need to find the intersection point closest to the central port. Because the wires are on a grid, use the Manhattan distance for this measurement. While the wires do technically cross right at the central port, where they both start, this point does not count, nor does a wire count as crossing with itself. What? Oh, hang on. The central port is circle. It's just a location on the map. Oh, I see. So I don't think we need to use any geometry here. We don't need to draw any grid or anything. It's purely a numbers thing. Alright, I have an idea. So basically we want to keep track of all the pairs of coordinates that describe one edge of the wire. And we want to find crossing points, which means one pair is going horizontally and the other wire has taken the vertical, which is crossing that one. That's a simple arithmetic thing. we probably want to keep hash sets of each. So keep a hash set of all the pairs for wire 1, hash set of pairs for wire 2, and then you can just kind of cross-reference them, can't you? To see if they intersect. So you're not actually looking for... Well, you don't have a map. You don't have a visual map. I originally thought maybe you're looking for a plus symbol. But it's a little more difficult than that, because not only do you need to find a crossing point, but it's got to be a crossing point between 2 different wires. But I think this is alright. Manhattan distance, yeah. And yeah, you just got to find the minimum across all of them. Okay. Wait, so these are 2 lines. There's 2 lines in this file. Okay. Right, I'm gonna say wire 1 equals hash set hang on. I see. So, for 2 wires to cross, you actually have to have a point where... Oh, I see, okay. So, you have a point, and for one of the wires, there is a horizontal line coming left of that point and right of that point. And for the other wire, there is a line going up and going down. That's what we're looking for. Okay, so one thing I want to keep track of is covered points 1. That means all the coordinates that wire 1 has ever hit. That's a separate set because it's useful to know. I think we'll need that. Then wire 2 is just another set. Okay. Hello, Warbro War. Welcome to Advent of Code. Would you share the question link? Yes. There we go. Advent of Code, year 2019, day 3. Have you used this site yourself? So, just wanna We've done some end of code. Did you do any of them live, like in December, or have you just mainly done archived ones? There's also a leaderboard link if you want to join my leaderboards. Oh, do I have it somewhere? Yeah, here it is. That's the leaderboard link if anyone in chat wants to join my leaderboard as well. Okay, so yeah, okay, so copy that. All right, so the first line is just a set of commands. So we want to wire one. Let's say, okay, commands one. That's wire one's commands equals. So it's going to be. Hang on. Let's say x, y equals 0, 0. Okay, we start at 0, 0. Which is the origin that the wires start from. Okay, so we say for command in, it's going to be like this. Splitting on the comma, it's just going to be like this. Okay, so given a command, it's basically if it's right. Okay, so it's like if command dot starts with R, then it's going right. So you want x plus equal int of command, the rest of it. So it's going to be similar to this for each letter, but it's going to be like L. Let me do minus equal that, and then it'll be up and down. So up, then we'd want y plus, and if it's down, we want y minus. Okay. Oh. Okay, but we want to store the pair, so we want to say old x, old y equals x, y. We want to know where we came from as well. Okay, so then we update x and y. So we've got a origin, a source, and a destination. And basically that is one edge that we're going to add. So it should actually be, let's call it edges 1. Edges is a better term here. Right, so edges 1 dot add. So it would be basically old x, old y. Yeah. To x, y. But direction doesn't matter, so for the sake of the set, we want to add the opposite way around too. So basically that edge is stored orderless. Okay. And also all the covered points, we want to keep them up to date as well. So we can just say covered points dot add just the new destination, I guess. Okay. Bit of a mouthful. Okay, but is this still part 1? Yeah, it is. Okay. It's an involved part 1, I guess. Right, but that's just the first wire. But now the second wire is easy. We just copy and paste that. So we say, we can just copy and paste it. So then we reset X and Y. Get the next line. So it's the same code, old XY, blah, blah, blah. The only thing we change is edges 2. And we don't bother storing cover points. Okay, so I think what I've done is I've translated this input into a set of edges. Let's run it and see if we've got something. Print edges 1, print edges 2. Yeah, this has to be a pair of pairs. So it'd be like that. And it, okay. Okay, that looks plausible. All right, so now we want to basically find the minimum Manhattan distance to the origin out of all possible intersection points. Okay, every intersection point is necessarily a point that wire 1 visited, so we only have to check all the points here. Okay, so the so best dist starts off as none, let's say. Or so for let's say, I don't know, px py in covered points 1. Okay, so this is every candidate for intersection point. Now to check if this is an intersection point, we have to check either edge wire 1 has 2 vertical lines through it and wire 2 has horizontal lines through it, or the other way around. So let's try and phrase that. So let's say if wire 1, okay, let's say wire 1 has 2 horizontal lines. So it'll be px -1 to px, no, py, and this is one edge going to px py, so that is one edge in edges 1, and basically the same thing but from px to px plus 1. and for vertical, we want px py to px py plus 1. And that's in edges 2. I hope I've understood this intersection thing correctly. And px, py, it doesn't matter the order, so we can do, okay, we can do this -1 like that. So if all 4 of those conditions are true, that means we've basically built an intersection using 4 pieces. Is this how I... Is this one long line? Can I not just do that? It doesn't like me doing that. No. Okay. Keep it on one line then. So if it's an intersection point, then distance is going to be the absolute value of px plus the absolute value py. That's the Manhattan distance. If best dist is none, or d is smaller than the best we found so far, because we want the shortest distance, then best dist is updated to be d. But now we have to do that whole thing. Well, I could make this a long... Alright, so this is one condition. Or that whole thing again, but just swap 1 and 2. I'm sure there's a way of simplifying this, like removing the amount of ordering we're doing. Alright, so this is an edges 2, and then the other one is an edges 1, edges 1. So if either of those are true, that's an intersection point. Okay. This was one wordy solution. Okay, print best dist. None. We didn't find any intersection points. Alright, DIJ. See you next time. Have a good rest. Okay, it's weird. Wait, these numbers look strange. Oh, I just realized something. Oh, I've done this horribly wrong. We've got to add all the this L command 106, we've got to treat it as if it's go left 106 times. Of course. Because I'm just yeah, of course, this is not going to work. We have to adjust. Okay, this condition's correct. We have to break this whole thing into oh man, this is gonna look messy. Okay, let's rewrite this. So we say prefix equals the first letter, and num equals int command 1. Okay, so we can just say if prefix equals r, it's just to clean this up a bit. Alright, so use prefix. Now we want to do this whole thing num times. So we can treat it as if we just had that command 100 times. I think the numbers are fine, it won't take too long. So for each of those, we do this, and then we do this whole thing for each of those. So we put the edge in, and we update the covered points. So basically we just expand this as if it said up, 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 up. You could actually just change this input to say R, 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 R 1,000 times and so on, and that would actually work, but okay, we can do it like this, and then this whole thing has to be copied. Here, but we swap this to be edges 2. Alright. That better? It's gonna take a while now because there's a lot, but... Okay, still no crossing points. Don't print this stuff because there's too many. Print length of edges 1. Length of edges 2. So there's 300,000, 300,000, and for some reason we're not finding any crossing points. Let me just always put px first. Px minus 1. So we do x minus 1, x plus 1, y plus 1, y minus 1. And then over here, I just change this. I want to just have them all use the same format. X minus 1, x plus 1 in edges 2, and y plus 1, y minus 1 in edges 1. So we didn't find any crossing points. Okay. There's a big problem here. That should be moved to inside the for loop. Whoops. Yeah, that's a bug. Otherwise, we're not keeping old to be one space away from new. So then we're adding weird lengths of edges. Okay, yeah. That's just plain wrong. Okay, try now. Still none, okay. This is an unbounded area, right? Infinite field, yes. It's unbounded. Okay, any other obvious issues? Otherwise I just will try the example. Oh, this is wrong as well. God damn it. This should be add 1. Add 1, because I removed... that became obsolete. We don't need to do that anymore. There we go. Yeah, these should all be 1. So again, I was adding weird lengths of edges. Now it's just individual 1 length edges. Okay. There we go. We've got something. 1064? I don't have a strong, good feeling about this, but it's a start. Oh, it's correct. Okay. It's tricky to put that all together, but conceptually it's not difficult, I guess. It's just you gotta keep track of all the different edges you've created and ignore the time at which they were visited, because I think the mistake some people might make is try to run these two wires in parallel and see if they cross. You're trying to see if, you know, an early part of the wire might cross a late part of the second wire, so you basically got to keep a hash set, or at least a hash set is the most efficient way of doing it, I guess, of all the visited points, and just be careful about the definition of an intersection, I suppose. Yeah, it needs a lot of careful coding there. It's not particularly easy, and that's part one. So, part two. It turns out that this circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wires' steps is lowest. If a wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value of a specific intersection. This is not much harder. We just need to keep an additional hash map, which is time visited, and make sure we keep the first time. Okay, I think this is an easy change. So this was part one. So part two is mostly copy and pasting that, but before we do that, we need to just add in one hash map. So we're going to have another map which says time visited 1, and it's going to visit 0, 0 at time 0. Time visited 2. All right, so every time we move to a new XY value, all right, we're gonna have to set time equals 0. So X, Y have been updated. Let's say time is increased by 1. We add in the edges, cover points, and then finally we update time visited 1 XY. Oh, this is gonna be the first time. So if XY is not already in time visited, then we add it for the first time, equals T, time. Alright, so we have to do the same here. It's kind of bad that I've replicated this whole code twice. There's a better way of doing it, but I can't be bothered to change it now. Time equals 0, so we want should I change it? Let's make the code cleaner. Okay, so let's say for wire in 1, 2, we do this whole thing. So edges equals edges 1 if wire is 1, else edges 2. And then we do all this, and then here we do edges instead of edges 1. If and only for the first wire, we do that. And we want time visited equals time 1 if y equals 1, else 2. And then there. Okay, now we don't need this whole repetition here. Hopefully it's correct. So now we should be... Make sure we still get the same answer now. Yeah, we do. Okay, and now for part 2, we do this again. But instead of best dist, it's gonna be best times, because it's like sum of times. Let's just call it best times equals none. And then for all of this, we say t equals time visited px py plus, so it's going to be time visited 1. Basically the sum of the two times. So that's part 2. 2, 5, 6, 7, 6. Have I done the same? Have I done the correct thing at the end? Use combined steps. I think so. Correct. Oh, this is a nice problem. I think there's a lot of wrong directions people could go in when attempting that problem, like trying to, like I said before, like trying to simulate each step. But that's a bad approach because you need to know the full range of steps it takes from the beginning to the end, because an early part of a wire could clash with a late part of the other wire. So you've got to treat it timeless, but you've also got to record the time as well. So yeah. Yeah, pretty nice problem. Right, guess we move on to day 4. We are whizzing through these. Are we really? How long has that taken me? 1.5 hours to do 3 problems. That's half an hour per problem. That's kind of slow, to be honest. Considering these are like day 1, day 2, day 3. Oh well. That's, well, given that I'm kind of explaining what I'm doing as I go along, I guess that's fine. Okay, we'll move on to day 4. Nice short description. I do appreciate a nice short description. Turn off the AC. Okay, you arrive at the Venus fuel depot, only to discover it's protected by a password. The elves had written the password on a sticky note, but someone threw it out. However, they do remember a few key facts about the password. It is a 6-digit number. The value is within the range given in your puzzle input. So it's from this to that. Okay. 2 adjacent digits are the same. Going from left to right, the digits never decrease. They only ever increase or stay the same. How many different passwords within the... Seems easy. It's just a for loop and count whether it satisfies the password. Alright. We don't even have a large input here. We just need to... Okay, so it's gonna go from 197487 to that. Inclusive? Yeah. Alright. So if we want to determine whether a number satisfies the rules, let's make a define is match. Can't think of a better name for a given for a given number, D. So let's turn it into a list of integers. So it's going to be equals int x for x in string D. All right, so it just turns it into a list of its digits. That makes it easier to work with. All right. So let's go through the conditions. It is a 6-digit number. All right. If length L is not equal to 6, turn false. I mean, if we're in that range anyway, it should be fine. All right. Condition number 2 must be within that range. We're going to range through that range anyway, but I'll put this condition in anyway, just in case. So, if not in the range A to B, turn false. All right, the next condition. 2 adjacent digits are the same. There are 2 adjacent digits that are the same, okay. So we want if so basically turn this around, say if all digits are different to their neighbors, then we return false. So if all, so we want to say L I is not equal to L I plus 1 for I in range length L minus 1. We should just use some numbers here. N equals length of L. So if N, we want N minus 1 there. So if all neighboring digits are different to each other, return false. All right, and then the final condition. Going from left to right, the digits never decrease. Okay, so it's similar to what I just... Right, so if but we want to say if any, so we want to say if there is any digit such that it's strictly greater than its right neighbor, return false. And then if you get this far, return true. So part 1, we're just going to say print sum of map is match to the range A up to and including B. Nice compact way of saying that. So applying is match to each thing in that range. And that gets us a boolean. We just sum up those booleans and that interprets them as the integer 1 or 0. So what do we get? 1640. Correct. Part 2. And Elf just remembered one more important detail. The 2 adjacent matching digits are not part of a larger group of matching digits. What? The 2 adjacent matching digits are not part of a larger group of matching digits. Okay. So what they're saying is there is a double that isn't a triple. There exists a double somewhere. Oh, how do we phrase this exactly? Maybe there's a cleaner way of doing this. Just say, we're counting the number of runs, a run being a bunch of digits that are equal to each other in a row. So alternatively, we can just say either it's at the front, in which case the first 2 digits are the same and the 3rd digit is not equal, or it's at the end, in which those 2 digits are the same and the one before is not equal, or it's somewhere in the middle. Then what's easier? Should just do that. Okay, so let's say so the new condition is so we make a new is match 2. So as before, we do like this. So it has to be a match in the original criterion. So if not is match D return false. So we're just adding one more condition now. We're saying two adjacent matching digits. Okay, so let's say if there are two at the start, if L0 equals L1 and L1 is not equal to L2, return true. All right, that's one possible way. There's three ways this can happen. Or we can say if L minus 1 equals L minus 2 and L minus 2 is not equal to minus 3, return true. Finally, the middle, we can say if any, how do we do this? Say, if any let's say for a given I value, we say Li is not equal to Li plus 1 and Li plus 1 is equal to Li plus 2. So those are the two that are equal. And Li plus 2 is not equal to Li plus 3. So we can find any triplet, not even triplet, it's a quadruplet for I in range. So it's going to be n minus 4, I suppose. Return true. So there has to be at least one of these. Return true? I don't know if I've written that correctly. Okay, so part 2 is just this, but unsupported. Ah. So if we get here, return false. 16401015. So it's a smaller number, which is what we expect because it's a strictly tighter rule set. It's just a question of whether the logic was correct. Nope, it's too low. Oh, okay. I mean, the only... Let's have a look at these conditions again. L0 is L1, and L1 is not L2. So that's like the pair is at the start. Here, it's at the end. Not equal to L3. I feel like those are fine. So if any, we've got... should it be n minus... Should it be n minus 4? Just completed day 3. I'm on day 4 now. I'm just finishing it off. Well, hopefully just finishing it off. I have a mistake right now, but looks like I'm almost done. So you did day 3 then? Yeah, it was... day 3 was alright. A bit... My first iteration of writing it was a bit messy, but I cleaned it up a bit. Alright, so... Day 4... -1 equals -2, and -2 is -3, not equal to -3, return true. So it's this, I think the only thing that could be wrong, if anything, would be this condition right here. Oh. I think this should be n minus 3. Yeah, it should be n minus 3, not n minus 4. 1126. Yeah, it's just a bad indices. Those things are always confusing. There we go. Alright. Day 4 is a nice easy one, really. It's a short description and really just like one-line pieces of logic. You need to write it correctly, but yeah, straightforward. Before I move on, I can take a look at stats and stuff. Let's see. Well, first let's have a look at, I don't know, the leaderboard. I think some of my leaderboard people have done these problems in the past. Peveronia has done quite a lot of the problems, including the up-to-date ones. Okay. The stats for day 1. They solve them in like a minute or so. Yeah, I mean, that's what you expect, isn't it? Okay, that's not the stats I'm interested in. Where's the... Okay, well, this is the chart of... Okay, well... Yeah. Not much to glean from that. Let's move on to problem 5. It's just the trend you normally expect for the first few problems. A lot of people kind of stop doing advent of code after the first couple of problems. They decide it's not for them, so there's always a drop, but doesn't really give any indication of difficulty. Alright, so day 5. Hang on, just checking a couple of things. Alright then. Sunny with a chance of asteroids. 1 second. Alright, Sunny with a chance of asteroids. You're starting to sweat as the ship makes its way toward Mercury. Why are we going to all these planets again? Let's check the lore here. He's stranded at the edge of the solar system. So we're going to visit all the planets to get to him? Ah, so these are the orbit paths. Okay. Fine. The elves suggest that you get the air conditioner working by upgrading your ship computer to support the thermal environment supervision terminal. The test abbreviation starts by running a diagnostic program. The test diagnostic program will run on your existing int code computer after a few modifications. So we've got to reuse this, do we? Okay. First, you'll need to add 2 new instructions. Opcode 3 takes a single integer as input and saves it to the position given by its only parameter. For example, the instruction 350, take an input value and store it at address 50. Output 4 outputs the value of its only parameter. For example, the instruction 450 would output the value at address 50. Excuse me. Output. Alright, we're dealing with output now. Alright. Programs that use these instructions will come with documentation that explains what should be connected to the input and output. The program 304099 outputs whatever it gets as input, then holds. Okay. So we add those 2 new instructions. Second, you'll need to add support for parameter modes. Shall I just do these step by step so that we don't have to think about too much? Alright, let's start coding this first part. So, I want to copy essentially what I did here. Right, so we, as before, we get the program like this. Alright, so we say get result. So we create a copy of the original program. I assume we might not do this with A and B. We'll figure it out later. We do this. Okay. So the opcodes. If it's 99, we break. I'm not sure that we even return this anymore. So worry about that later. If it's 1, we do that. If it's 2, we do that. Yeah, okay. Elif opcode equals 3. Alright, so 3 says... also, we're taking different amounts of parameters now, so instead of doing this... we want to move these to here, because each has a different amount that it's gonna increase by. All right. If it's 3, single integer as input saves it to the position given by its only parameter. We'll take an input value and store it at address 50. Oh, I don't really get how this input-output thing works, so maybe we should read on. Alright, we'll carry on reading. I think I need to understand this more. Alright, parameter modes. It seems like this you'd actually do first before you do this, because this needs the next bit. Okay. Each parameter of an instruction is handled based on its parameter mode. Right now, your ship computer already understands parameter mode 0, position mode, which causes the parameter to be interpreted as a position. If the parameter is 50, its value is the value stored at address 50 in memory. Yeah. Okay. Now your ship computer will also need to handle parameters in mode 1. Immediate mode. In immediate mode, a parameter is interpreted as a value. If the parameter is 50, its value is simply 50. Okay. Parameter modes are stored in the same value as the instruction's opcode. The opcode is a 2-digit number based only on the 1s and 10s digit of the value. That is, the opcode is the rightmost 2 digits of the first value in an instruction. Parameter modes are single digits. Okay. Read right to left from the opcode. You're done with day 4? Well done. Yeah, I think day 4 is not too hard. There's just one piece of logic that's a bit tricky, but the rest is pretty straightforward. So the parameter mode is a single digits, 1 per parameter. Read right to left from the opcode. Oh, I see. The first parameter's mode is in the hundreds digit, second parameter's mode in the thousands digit, and so on. Any missing modes are 0. confusing. Okay, fine. The first instruction is a multiply instruction. Yeah, I get it, I guess. Alright, well... Parameters that an instruction writes to will never be in immediate mode. Okay. It's important to remember that the instruction pointer should increase by the number of values in the instruction. Yeah, okay. It just can be negative. Yeah, sure. The test diagnostic program will start by requesting from the user the ID of the system to test by running an input instruction. Provide it 1, the ID for the ship's air conditioner unit. Oh man, this is getting confusing. I still don't get this input-output thing. I need to day 2. Yeah, you do need to do day 2 before day 5. Because you're building on the same code you wrote for day 2. Then perform a series of diagnostic tests confirming that various parts of the Inco computer, like parameter modes, function correctly. For each test, it will run an output instruction indicating how far the result of the test was from the expected value, where 0 means the test was successful. Non-zero outputs mean that a function is not working correctly. Check the instructions that were run before the output instruction to see which one failed. Finally, the program will output a diagnostic code and immediately halt. I'm so confused. What diagnostic code does the program produce? All right, so the first, okay, so we give it input, which is 1. I see. And we wait for it to give an output. It will give us 2 outputs, essentially. First, it will give it the result of the test. And then the second output will be a diagnostic code. And then it will halt. What we want to give right now is the second one. Fine. Oh man, it's quite a lot to take in here. So basically we change this. We don't use this anymore. Instead we have a thing called I don't know. We don't want to call it input. Just say I. No, not I. Just in. Call it imp. So make a copy here. We don't change any of the parameters to begin with. So while true, so this is kind of modified now. Okay. Let's say so now we've got opcode and something else combined into one thing. So we need to unpack the modes. Okay, so opcode is temp program. So it's going to be let's say turn that to a string and just take the last two values. That's the opcode. And then these are all going to be strings. Might as well just keep them as strings because they shouldn't be interpreted as an integer really. Just put some placeholders here for should we put 99 at the end? Just put them in order now. Okay. Okay, so the opcode is that. All right. The modes is going to be string. So it's going to be this, but we want everything up to the last two digits. And then we kind of want to turn it around, reverse it. So the modes, that will give us the modes. And it'll be a series of strings, so we need to unpack that. Okay, and then all right, so we're going to need a helper program here. Define get, let's say get val. So it's going to take parameters. Oh, how are we going to do this? No. We should probably add some zeros to the end of this, just to make sure we don't get an out of bounds thing. So in the worst case, we would have So in addition, you've got two numbers to add and then the result where you put them. The most number of modes you would ever have is 2, right? No, it said third parameters mode. Why would there ever be a third? Any missing modes are 0. I think we would only ever need 2 at most. So I'll just assume that. But it will crash if it doesn't, and then we'll know. So let's just add 0, 0. So that we don't go out of bounds. Alright, so get value takes a num, let's say, and mode, which is going to be 0, 1, and it's just telling us if mode is 0, then we return whatever's at the address. So it's going to be program num, else elif mode is 1, just in case there's new modes introduced later on. Return just the value itself, right? So this helper program is what we use. So now all of these can be changed. We can say, so for addition, alright, I'm just going to call it program from now on. Or should we just call it P, because this is getting so wordy. Alright, we'll just call it P. P. Look how much cleaner that is now. Huh. Just replace all these. I could do find and replace, but I'm doing it manually just to check everything. Okay. Right, so let's rewrite this one. So we're saying, so this stays the same because you can, if you're writing to a location, you always use the locations, not value. So this will change to get val. So we take whatever we see in IP+1 and couple it with the mode. And the mode is going to be modes 0. And then we do the same here. We do +2 and take modes 1. So we take the next mode along. And so it could be by reference, it could be by value, but the get value will decide that. Okay, it's a bit confusing, but... So here it's similar, but we... Stop leaving spaces after my... Oh, for goodness sake. It's just the line's too long if I do that. Alright, so here it's pretty much the same. But we multiply. Alright, so those are similar to what we had before. Now for 3. Let's have a look. So, opcode 3. So it takes the input and saves it to the position given by its only parameter. Alright, so we say... So that's the location we're stored. And we just take imp, which is what the number we were given to start with. Okay. Opcode 4 outputs the value of its only parameter. So, but we need to use get val, don't we? So we say, so we're going to yield, because we can output multiple times. Yield get val of so it's going to be key IP plus 1. With modes 0. And just yield it. Okay, and 99 we break, and anything else is an error, but we also break. Okay. So we've got our program. Making a copy for this. So for part 1, what are we doing? So we provide 1. So we run this with, we provide the number 1 as the input. So we do for x in, so we get 2 numbers here. We should get 2 numbers. So we get result in x. Let's see what happens. Oh, stop. One thing I need to do is increase the instruction pointer. Otherwise we get infinite loop, like we just did. So here we add 2. So we just add 2 in these cases, don't we? There's only 1 parameter. Okay, let's try. For x in get result, for given input. Okay, we're not getting any output. It's gonna be a pain to debug this. So that's the program there. Do we need a return statement here? Because it's a yielding program, so I guess we just do that. I don't know. No, that doesn't change anything. Oh dear. Okay, should we try the example? Because this is complicated, so... Oh, damn. The opcode has leading zeros. I gotta get rid of those leading zeros. So actually, we should actually go back to using ints. It should actually be interpreted as an int. Because that will match. Okay. Print x 0. So what are the zeros? The zeros mean successful test. So we got successful tests for all of these, and then we got a diagnostic. So hopefully this is correct then. Correct. The air conditioner comes online. Yay! It's cold air, feels good for a while, but then the test alarms start to go off. So Since the air conditioner can't vent its heat anywhere but back into the spacecraft, it's actually making the air inside the ship warmer. Yes, thermodynamics. It's a closed system, so the amount of entropy will only increase, right? Or the amount of heat will only increase. Instead, you'll need to use the test to extend the thermal radiators. What's that? Okay, it's stuff that's used in spacecraft. Fortunately, the diagnostic program is already equipped for this. Unfortunately, your encode computer is not. Oh no. Four more commands. Wonderful. Okay. Like all instructions, these instructions need to support parameter modes as described above. Okay. It's getting complicated now. As if it wasn't complicated already. How long is the stream been going? 2.5 hours? Okay, this is the last problem. And then I'm gonna sign off. Alright, well, let's start by coding in these opcodes. Okay, support parameter modes as before. If the instruction modifies the instruction pointer, that value is used and the instruction pointer is not automatically increased. But where's the instruction pointer? Ah, there, it's actually set specifically by certain commands. Interesting. Okay. Is that all? If we just put those in, will it just work? It doesn't look like we have to do anything else. And we run it using input 5. Okay, should just work if we do it correctly. It's nothing, doesn't seem to be too bad then. So, let's modify the original program. Alright, so if it's 5, so 5, jump if true. If the first parameter is non-zero, so there's 2 parameters. So we basically do if, so the first parameter is non-zero, so you want if get val IP plus 1 modes 0. Is not equal to 0. then the instruction pointer. So we say IP equals, so it's going to be get val of this is 2 modes 1. See, all this manual changing of indices is probably should have been handled by get val, but whatever. So we need an else IP plus equal 3. So skip over the opcode and those 2 parameters. Okay, that's opcode 5. Opcode 6. What have we got? Jump if false. If the first parameter is 0, it sets the instruction pointer to the value from the second parameter. Otherwise it does nothing. So it's almost exactly the same. That's just equals 0. Nice and easy. If the first parameter is 0, yeah, that's it for 6. Okay, 7. Less than. If the first parameter is less than the second parameter, it stores 1 in the position given by the third parameter. Otherwise, it stores 0. Okay. So it's basically like addition in terms of numbers of parameters. So we can take this and say, so whatever we store in the third parameter is going to be a 1 if, so we're going to have get val, first parameter is less than the second parameter. It's going to be less than get val once 1 else 0. So we set it to 1 if it's less than, otherwise 0. And IP plus equal 4, because there's 3 parameters. And then 8. Equals. So it's the same as this, except 1 if get value is equal to that, else 0. And then plus equal 4. Okay, that didn't seem too bad. So if we try running that same program on test 1, I think we will get the same result because it's not using those new commands. Hope so. Good. Okay. So part 1, you just do 1. And it doesn't matter that the program is modified. Okay. And then we want to run this on test 5. Is that right? We get that. Is that it? Nice easy part 2, please. Hopefully. Are we getting what we're expecting? We should only get the diagnostic code. Indeed, we only get the diagnostic code, so that's a good sign. Yeah, that was a nice easy part 2. They could have... It seems like they were setting up for something more complex with all this parameter stuff and all this outputting of diagnostic numbers. I reckon they're going to reuse this code for a later part, a later day, because why else would they introduce all this diagnostic stuff? Like, why are they outputting all these test values if we're not actually using them? We'll see. And with that, I think we'll stop there then. So that was 5 days done. 1/5 of the way there, 20%. In how long? 2.5 hours roughly. So like half an hour per problem. I think that's fine. Later on, it'll become like several hours for a problem. That's how it was in previous years. So we can see we're starting from Earth. We've gone to Venus. And we've gone to Mercury. You take a sneak peek of 6. Oh, it's a graph problem. Oh, I'm tempted to do another problem. Shall I? Shall I do one more? Yeah, go on. Let's do one more. Alright, moving on to 6. Day 6. Warbro War. I don't know if you're still doing these problems, but day 6 is one that you don't need any prior to have done anything prior to, so you might prefer to do day 6 instead of day 5 if you're still doing them. Because yeah, day 5 you need to build on day 2, and it takes a while. Okay, so what have we got here? Oops. Alright, day 6, Universal Orbit Map. You've landed at the Universal Orbit Map facility on Mercury. Because navigation in space often involves transferring between orbits, the orbit maps here are useful for finding efficient routes between, for example, you and Santa. You download a map of the local orbits, your puzzle input. Okay. Interesting. Except for the universal center of mass, COM, every object in space is in orbit around exactly one other object. An orbit looks roughly like this. Huh. Okay. So this says BBB is orbiting around AAA. In this diagram, the object BBB is in orbit around AAA. Okay. Before you use your map data to plot a course, you need to make sure it wasn't corrupted during the download. To verify maps, the Universal Orbit Map facility uses orbit count checksums. The total number of direct orbits and indirect orbits. Ooh, okay. Whenever A orbits B and B orbits C, then A indirectly orbits C. So first we want to build a direct graph, and then we want to do something with that, I guess. Okay. So yeah, we want to make a direct graph. That's easy enough. And then probably we want to use a recursion to count all the indirect. Alright, so we've got D orbits C, and also indirectly orbits B and COM. So basically you want to recursively call orbits to get... Yeah, we can do this. COM orbits nothing. Okay. Okay, first let's make our graph. Go. Alright. So basically we just want Just copy some code from before. Let's say like this. So for the input, we basically got two values. It's going to be string A and string B. So it's going to be string. So it's going to be A and B equals. So we want. It's going to be f.readline.split on the open bracket symbol. It's a weird one. Programmers don't like to see an open bracket without a closed bracket, but that's what we're using apparently. It's a closed bracket. Whoops. So in our graph, we're going to create a class graph. Self.edges equals right, I want to import default dict here. Very useful library. It's just a dictionary with sensible defaults. So we're going to do default dict on a set. No. Yeah, set. So a string gets mapped to a set of all strings which it orbits. Yeah. So these are its children in the graph. So G equals graph. All right. So A, B, so basically we do B orbits A, essentially. So we're saying G dot edges B dot add A. So we're saying in this hash map, whether B exists or not, already in this hash map, we're adding A to its set. So to start off with, it'll just be an empty set by default, and that's what default dict uses. So now we've got our graph. We could try printing the graph. Okay. Print graph.edges. Of course, I didn't do for line in f dot read lines. We didn't get all of them. Also, dot strip dot split because we're using a string, so we want to get rid of the new line characters. There we go. It's mostly singletons. Is it just one chain? Can't be right. Oh no, that's correct. That's correct. Each entity only orbits one thing. Yeah. If you go backwards, each thing is orbited by multiple things, possibly. But we're going in the direction of orbiting, right? So now what? We want a method to get all descendants. So for graph, define get descendants for a given object. So this means get all the children and the children's children and the children's children and so on. So we just want the number, don't we? And we've only got one child, but let's pretend we have multiple children just in case. I don't know. Make it generic. So total equals 0 for child in self.edges s. So these are each of its children. We're gonna add 1 for the child, and then we're going to add the recursive call. So it's going to be self.get descendants of the child. So we add 1 for the child and get all the descendants of the child and add 1 for each of them as well. And return total. So running this on each thing is probably like quadratic or cubic or something, but it seems... we might need memorization here if it's cubic. Hang on, so it's going to be... No, it's going to be quadratic. It'll be fine. So, okay, so result equals 0. So for just like, I don't know, x in g.edges.keys. So that's basically all the possible things. That have children. We want result plus equal g.get descendants x. So some things will be counted multiple times because they're indirectly descendants of other things. Print result, is that it? So they asked for the total number of direct and indirect orbits. Which is basically what get descendants gives. So let's try running that. Okay, edges.keys. Dictionary change size during iteration. What? Does this change anything? Ah, because it's looking up something which might not exist in edges, so it creates a new entry. Interesting. Okay, fine. Let's just create a list of all... Oh, are these planets? Let me use the right terminology here. No, they're just objects. Okay. Let's say objects equals set objects.add A, objects.add B. Alright, so now we know all possible objects. Shouldn't matter if the graph modifies on the fly because of the default dict. 268504. Correct. Now you just need to figure out how many orbital transfers you need to get to Santa. You start at the object you are orbiting. Your destination is the object San is orbiting. An orbital transfer lets you move from any object to an object orbiting or orbited by that object. So it's bidirectional graph, basically. Okay, so this is just breadth first search, isn't it? For example, suppose you have the following map. Right, we want to make a digraph out of what we have currently. So yeah. So you are in orbit around K, and San is orbit around I. So we want to find the distance from K to I, basically, using breadth first search. Alright. So I would be tempted to make a separate type of graph for this. Oh, no. We can do this all in one. So we can say we have a thing called orbit, which is a one-way directional thing. This is what we use for part 1. And then we have a thing called edges, which is just a set of edges going... It doesn't matter which way around you're orbiting. And that's also a default text set. So when we add our things, we have to distinguish orbit and edges. So basically, we can define add orbit. So we're saying X orbits Y. In this case, self.orbit x.add y. Okay. Self.edges x.add y. But the point of edges is bidirectional. So self.edges y.add x. So we're still able to get descendants because we've stored the directional graph in orbit. But edges gives us like a generic undirected graph. So here we can just do g dot add orbit b orbits a. And as before, we can get all objects. Okay. So the graph is don't need to create a new graph. Part 2. So there should be a something called U. Oh, I see. Okay. And then there should be something called sand. All right. So we want to get the start point. That's where we are. You. So start equals so it's going to be graph dot get graph dot orbit graph dot, let's call it orbits because it's like it's technically plural even though it's let's tighten this down. So let's say orbit must be one thing, one and only one thing. So orbit is not a set. It can be a string, I guess. Either the thing it orbits or the empty string. So here, orbit of x equals y. And if we don't do this, then if we ever call itself to orbits x, we'll get an empty string. Alright, we might need to change a couple of things now. So we don't need this, we just say if it orbits something. If it doesn't, it's going to be 0. So if it orbits something, then total plus equal 1 for that thing, and total plus equal self dot descendants of its whatever it's orbiting. That's kind of safer because we're not using lists of children anymore. It's just you can only orbit one thing. I mean, if we're doing this, it makes more sense to not use default dict for that at all. This should just be a normal hash map. Yeah. So this is just going to be a normal hash map now. So yeah, this stays the same. And here, if, so we want to say if s in self dot orbits. That means it orbits something, otherwise don't do anything. Yeah, okay. Let's make sure we get the same result. 268. 268. Okay, all right, part 2. Start equals g dot orbits. Now we can just do this one-liner here. U. Goal equals g dot orbits san. Print start goal. Nice. Now finally we just want a method that finds the distance between them. Alright, so this is just breadth first search. So we're gonna do, I mean, it can just be depth first search because there's no cycles. So if we find a path, we're done. No, because depth first we don't normally... Yeah, depth first. Alright, so we need a queue, which is going to be just a list. We need a dist function, which is just going to be a hash map, which, so we start off with that start, whose distance is 0. While there is stuff on the queue, current equals queue dot pop. And then we just say for neighbors in self.edges current. That gives us all the neighbors of current. If for neighbor in, if neighbor in dist, that means we visited it already, so skip that one. So we've got a new neighbor. If neighbor is goal, we simply return dist of current plus 1. That's the distance to goal. It's whatever it was to get to current and then add 1. Otherwise, if we got this far, we just put it into the queue. So we say dist of neighbor equals dist of current. It's 1 queue dot end neighbor. So we just do that until the queue is empty. If the queue does get empty, that means they're not connected. So technically it's infinite distance. I don't know. If that happens, then just print error. No, not connected. Shouldn't happen. Alright, so part 2 should just return that, right? Let's see. Print start print graph the g dot get dist start goal. 409. I feel like that might just be right. It's like if it found something, then the only thing I could get wrong maybe is I'm 1 off, but we'll see. Correct. Nice. Okay. Nice. Graph problem. That's like the most basic fundamental graph problem. Find the distance between 2 points. because everything else kind of builds up on that concept. Once you know how to find distance between 2 points, you can do a lot of other things. It's just graph traversal, and depth first search is the most basic distance function, because it doesn't worry about the fact that you can reach a destination via multiple different paths. In this case, there's only one path you could ever reach a point from, so the moment you find it, you found the shortest path. But in general, it's not correct. You have to use breadth first search to get the general case correct distance. And if your edges are not distance 1 each, then you have to use Dijkstra's algorithm, whatever. And if it's a really, 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 really complex graph, then you should probably use A star, because you need to use some heuristics. But anyway, that was the most easy one. We probably will end up using Dijkstra's algorithm in some later problems. Okay. Alright, I'll finish there. Day 6 is done. Orbit. Elliptical orbits are... This is making me want to play Kerbal Space Program now, which goes into surprising amounts of mathematical depth with orbits, because you have like a... In Kerbal Space Program, like the key is really to understand the what is it? Like the apoptosis. I don't even know how to write it. Apoptosis. No, that's a biological thing. Orbit. Apophis? No, that's a planet. Or a sun or something. Orbit. Kerbal Space Program terms. I'm sure they'll have them. Terminology. Here we are. Apoapsis and periapsis. I was way off. Okay. Like, periapsis is your closest point to where you're orbiting, and apoapsis is your furthest point. And in Kerbal Space Program, the game, you kind of... If you want to get close to a point, you have to decrease your periapsis. And if you want to break out of orbit, you want to increase your apoapsis. Because if you decrease your periapsis, then when you reach your periapsis, you're going to be within, like, the capture gravity, and then when gravity will take over, and then you'll just fall. I think. I might be talking complete trash. I don't know. I can't remember how to play that game. And if you're trying to break out of orbit, then you want to increase your apoapsis. I don't know. Oh, it probably says right here. Prograde. Anyway, we're going way off topic. This is not needed for this problem, or any problems in Adventive Code, I'm sure. Check out the stats. All right, so we just did 5 and 6. Catching up to my colleagues here. I'm guessing Patagonia did these problems a long time ago and just never finished. Umara, if you're watching, you need to catch up as well. Because 2019 I've started now. Yep. So Captain Coder. Well, yeah, he hasn't done them, so there's no point checking Captain Coder's leaderboard. Let's have a look at these times. 6, 4 minutes, yeah, whatever. 5, it was the harder one. This one took people 22 minutes in the worst case in the top 100. That sounds about right. 6, like half the time. 6 is, I'm surprised it even took them as long as that. But then again, this was a few years ago. Not many people knew about Advent of Code compared to now. I think if you did this now, it'd be much faster because there's way more people doing it. I think if I wasn't streaming this, I could actually beat that time. Yeah, if I'm just not worrying about writing good variable names and all that stuff, it's just breadth first search, which you can have pre-prepared, or just copy and paste in my pre-prepared depth first search code, because that's just paste it in. I think I could probably beat that. Paste in my pre-prepared graph code. Yeah. Should only take a matter of minutes. Okay. That's it then. So, I don't know when the next stream will be. If I can manage tomorrow, then I'll do it tomorrow. Otherwise, not sure yet. Maybe in a few days' time. But that's 1 to 6, and that's a good rate of days per stream. That's probably not going to be able to match that in any of the future streams. It's going to get harder. But yeah, I hope anyone who watches this found it instructional. I got some positive feedback from, like, a lot of people found my 2023 videos on YouTube and seemed to like learning from them. So hopefully I can do the same with these videos. I mean, this is an old year, so people might not be interested in 2019 as much as they are in the newer years. But it is an archived year anyway, so some people might want to catch up. Like, you're only a true Advent of Coder if you've got all the stars. That means 450 stars. And this year, 2024 December, you can bring that up to 500. And then later on in the year, I guess I'll do 2021 to get that ticked off. What is that a map of? Should we take a sneak peek? It's a bit naughty. We shouldn't be looking at this, but... Ship at sea. Oh, it's something about marine something or other. Okay, cool. 2019 was in space, and they had lots of assembly code problems, it seems, because we already had 2 within the first 6 days. I know a lot of people don't like those assembly code problems because not only are they quite complex, but they build on previous problems. I think a lot of people like independent problems because if they're stuck on a problem, they like to be able to just move on to a new problem and not worry about that. But this one you actually needed to solve 2 before 5 and so on, and there may be more later on. So I know there are a lot of people that don't like those problems. Probably more people who dislike them than there are who like them, but if you're a programmer, you've got to expose yourself to all of these kinds of things. So it's just something you have to deal with. And I was actually watching Observer Herb streaming the video game TIS 100 a few days ago. But that game is basically assembly code, the game, which I would like to play one day. But a little bit more fun than actual assembly code programming, I would hope. Bit gamified. But yeah, shout out to Eric Wastel, who made this site, and he visited my stream in one of the previous years. I can't remember. I think it might have been 2022. But yeah, I'm sure he's working hard right now on this year's Advent of Code, because it only gets more and more popular with every year. This is the new thing. Competitive coding is dying. Now people want to be less competitive, I think. And this is what this site provides. It's not as competitive. I mean, the leaderboards are there. It's only the top 100, but it's there if you want to be competitive. But I think most people are just in it because it's fun and people are discussing stuff. All the competitive sites like HackerRank, Google CodeChamp, those are both shut down. They don't have competitions anymore. Code Chefs is still up. But I feel like the scene is dying because everyone's just using it to get jobs and no one really does it as a hobby anymore, or at least the number of people doing it as a hobby are a smaller set of people and they are insanely good at it. So you feel like you can't compete. But this site is just way more fun than any of them. Everyone's kind of just explaining how they did stuff. You can find videos. Some people like to complete them in esoteric ways, like solve them in Minecraft or solve them in Factorio or in Satisfactory, or even just like, I don't know, solve it in Pokemon, because Pokemon you can do Ace, can't you? Arbitrary code executions. So, all right, well, see you next time. Happy Advent of Coding.